Hey, this is a video for the review worksheet for the topic 6 test. And the first question on the review sheet is to write the cube root of 10 with rational exponents. So in other words, write it with a fractional. So 10 is to the first power. So this is the same as 10 to the 1/3. Number 2, we have 5 to the x over 3 times 5 to the x over 5 equals 5 to the 4th. First thing we have to do is we have to combine these. And the way we do that is by adding the exponents. So I need to take x over 3 plus x over 5. Common denominator would be 15, which means this new numerator would be 5x. And 15 here, which means that new numerator would be 3x. When I add those together, I get 5 to the 8x over 15 equals 5 to the 4th. And now I can set the exponents equal to each other. And so we get 8x over 15 equals 4. And I put that over 1, and then I cross multiply. And I noticed that when some of you cross multiply, you want to put 8x over 60. And then my question is, what happened to your equal sign? When you cross multiply, here to here, I get 8x, and here to here, 15 times 4 is 60. And then I divide both sides by 8. So x is, I reduce that fraction, and I get 15 over 2. Remember my policy, if you start with fractions, then you should end with fractions. If you start with decimals, then it would be okay to end with decimals. But this is definitely a fractional answer is what we should have there. Number 3, solve the equation 1 over 49 to the x plus 2 equals 7 to the x minus 3. And so we need to get the bases to match. 1 over 49 is 7 to the negative 2. It's 1 over 7 squared, which is 7 to the negative 2. And then when we have a power raised to a power, we multiply the exponents. So that's going to be 7 to the negative 2x minus 4 equals 7 to the x minus 3. And now that I have the same base on both sides raised to a power, I can set those powers equal to each other. So negative 2x minus 4 equals x minus 3. And I would probably subtract the x from both sides to solve this. And then I would have negative 3x minus 4 equals negative 3. And then I would add 4 to both sides and get negative 3x equals 1. And then I would divide both sides by negative 3. X is negative 1/3 or 1 over negative 3, however you want to write that. Okay. Number 4, we have 10 to the x to the 2/3 over 10 to the 1/3 equals 10. And here's a little trick that we can do to shorten up this problem. I can just subtract these exponents. 2/3 minus 1/3 is 1/3. And so that would give me 10 to the x to the 1/3 equals 10. And then again, I would multiply these exponents. So that's 10 to the x over 3 equals 10 to the first power. And so my equation is x over 3 equals 1. Multiply both sides by 3 or cross multiply, you get x equals 3. And I've done something wrong. Well, that's not the right answer. Don't know what I did wrong, so let's start over. It's usually a good place to start. Over, that is. So if I do 10 to the 2x over 3 over 10 to the 1/3 equals 10, I could do 10 to the 2x over 3 minus 1/3 equals 10 to the first power. 2x over 3 minus 1/3 equals 1. And so if we add 1/3 to both sides here, I get 2x over 3. 3/3 plus 1/3 is 4/3. And if I cross multiply, 6x equals 12, x equals 2. So that is the correct answer. Not sure what happened above there, but bear with me. It's our snow day, remote learning day, and so I'm just doing some schoolwork. So number 5, identify the key features of the exponential function f of x equals 10 to the x. And so if you recall, we talked about, if this number being raised to the x is a whole number, this graph is going to look, something like this, where it's climbing fast and it's getting closer and closer to that axis, but it's never going to get there. And the key features is it wants you to name the domain. There's no restriction on the domain. The domain is all real numbers. And then it wants you to give the answer for the range. And the range is, it's never going to get below that x-axis or be on that x-axis. So its y is greater than 0. I want you to give the equation of the asymptote. And remember, the asymptote is the x-axis. The x-axis is a horizontal line. So horizontal lines are y equals lines. And on the x-axis, y equals 0. And then it wants you to give the y-intercept. And the y-intercept is, when I plug in 0 to this equation, what do I get? And anything to the 0 power is 1. Okay. Number 6, we are supposed to graph f of x equals 6 to the x. And again, there'll be graph paper on the test, and it's a limited field. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 1, 2, 3, 2, 3. So if I plug in 0, I get 1. If I plug in 1, I get 6. If I plug in 2, I get 36. Obviously, that's not going to fit on my graph. If I plug in -1, I get 1/6, which is darn close to this x-axis already. And then it keeps getting smaller and smaller and smaller. And so, that's the best that we can do as far as points. Number 7 has a table of values and x values, and it gives you the f of x values, so the x and the y values. And it gives you that at 0 is 6, 1 is 12, 2 is 24, 3 is 48, and 4 is 96. And so the way we figure out, it wants us to write the exponential function that would cover this set of data. And that is of the form f of x equals a times b to the x. Remember, a is the first term. What is it? What is the term when x is 0? And so in this particular example or problem, whatever you want to call it. The first term is 6. B is that common ratio. It's what I'm going up by. So looks like times 2 times 2 times 2 times 2. So 2 to the x, and that's the answer. Okay. Number 8. We have Inez, who saves $5, and then she doubles the amount she saves each week. Does this represent an exponential function? Well, so that means she would have 5, then she would have 10, then she would have 20, then she would have 40, then she would have 80, and so on. Is that exponential? Well, I think so, because I multiplied by 2 each time. So to complete the sentence there, this does represent an exponential function because his savings increase by a constant ratio. And that's all that they're asking there. It's vocabulary in nature. So constant ratio, common ratio, we call this thing both of that. Okay. Population of a town is 14,000. And it grows at a rate of 4% per year. What will the population be in 6 years? So this is strictly just exponential growth. I'm going to plug that into A of n equals a sub 0 times 1 plus r to the n. I'm pretty sure that's not the variables that are up on the board, but it's the same equation. So what am I starting with? I'm starting with 14,000 people. And the rate of growth is 0.04, and the time is 6 years. And so I plug that into my calculator, and I get 17714.47. So for on the review worksheet, that is C. It's a multiple choice question. And number 10. Tia invests $2,500 at an interest rate of 4%, compounded quarterly, and at the end of 5 years. Okay, so this is the compound interest. A sub n equals times 1 plus r over n to the nt. And n is how it's compounded. In this case, it's compounded quarterly, so n is 4. R is the interest rate, that's 0.04, and then the initial investment is $2,500. So I'm going to take 2,500 times 1 plus 0.04 over 4 to the 4 times 5. And some of you have been having trouble putting this in your calculator. If you put in the line 2,500 and then you put a parenthesis 1 plus 0.04 over 4 parenthesis, that's all fine. But then if you raise it to 4 times 5, when it does the times 5, that comes back down. Okay, so you either need to put this in parentheses, or I would just do that math in my head. 4 times 5 is 20. So I would raise this to the 20th power and work it that way. And I got, when I did this, I got 3,050.48. And it also is a multiple choice question. And D is the correct response there. Number 11. The population of a town is 18,000. And it decreases at a rate of 8% per year. So 8% per year. And in about how many years will the population be fewer than 11,000? So this is one where we're going to set it up as an exponential decay problem, where we're going to take 18,000 times 1 minus 0.08 to the t, or I think it's the x in our equations that I have up on the board, to the x. So basically we want to know when this is going to be less than 11,000, not 10,000. Okay. Well, it's the guess and check. You're going to plug in values for x until you get close to this. There's some shortcuts we can take. We can take 11,000, and I just did 10,000 on my calculator. We can take 11,000 divided by 18,000 and get 0.61 repeating, and then 1 minus 0.08 is 0.92 to the x. And now I just need to get, so if I take 0.92 to the 10th power, I get 0.43. If I take 0.92 to the 15th power, I get 0.28. So as I increase x, my y is getting smaller. So I need to decrease x from 10. So 0.92 to the 5th power is 0.65. So went a little bit too much. 0.92 to the 4th power is 0.71. 0.92 to the 6th power is the way I should have gone, is 0.606. So we're going to say that's close enough, because if I round it to the hundredths place, it would be 0.61. So x is approximately 6 years, and that is A. Hit 2 with a multiple choice question. Okay. That was number 11, and then it looks like I jumped to number 14. I must have forgotten how to count when I made this up. I eliminate problems and I move them around, and then sometimes I forget to renumber it all the way to the end. So it says 14, we're going to stick with that. The sequence is 10, 15, 22.5, 33.75, and so on. And is it a geometric sequence? And easiest way to tell is to take the second term, 15, divided by the first term, 10, and I get 1.5. And then take the third term, 22.5, and divide it by the second term, which is 15, and get 1.5. And if I were to keep doing that, I'm going to get 1.5 all the way through. So you're supposed to complete this sentence. The sequence has a common ratio, would be the first blank, common ratio. So it is a geometric sequence. So you're just filling in the blank with those words for number 14. Number 15 says, here's your geometric sequence, 540, 180, 60, 20, and so on, and write the explicit and recursive formulas for this geometric sequence. So explicit would be a sub n equals the first term, which is 540, times r, which I believe is 1/3. Yep. And that would need to be in parentheses to the n minus 1. And then the recursive formula, a sub n equals 1/3 times a sub n minus 1, and a sub 1 is 540. That's all there is to it. 16. The explicit formula for a geometric sequence, a sub n equals 6 times 3 to the n minus 1. What is the recursive formula for this sequence? So the recursive formula, a sub n equals the common ratio, 3 times a to the n minus 1, and then we have to say that the first term is 6. And that's it. 17, the recursive formula is a sub n equals 1/5 times a sub n minus 1, and a sub 1 is 125. And we're supposed to write the explicit formula. So the explicit formula, a sub n equals the first term, which is 125, times the common ratio, which is 1/5 to the n minus 1. Notice that I am putting those fractions in parentheses. So make note of that. 18. G of x is 2 to the x plus 6, not up in the exponent, down there, and f of x equals 2 to the x. And they're asking, how does the graph of this function differ from the graph of this function? And it is moved up 6 units. And that's all we're looking for there. And that is a multiple choice question. A is the answer. And last but not least, how does the graph of the function g of x equals 3 to the x plus 4, 4 is up in the exponent, differ from the graph of f of x equals 3 to the x? When the 4 is up here in the exponent, that means that this is going to moved 4 units left. Remember, when it's up in the exponent, we take the opposite. And that answer is D. And that's it. That's your review. So we'll have time in class to go over some questions, and then the test will follow.